Hey everyone, and welcome to this explainer. So, if you work in software engineering, you already know that keeping your systems reliable is, well, it's pretty much the most critical stage of development, right? But the way we actually monitor that reliability, that has changed drastically. Today, we're unpacking Chapter 11 from Observability Engineering, which outlines a massive and, frankly, much-needed paradigm shift in how we handle system health. We are going to explore exactly why the old way of monitoring your systems is probably driving your engineering team completely crazy, and how something called service-level objectives, or SLOs, offer a much smarter, user-centered path forward.
Okay, let's start with a little shared trauma, shall we? You're fast asleep, it's 2 a.m., and suddenly you are violently woken up by a pager alert. You drag yourself out of bed, log in, and the issue has inexplicably resolved itself. The on-call engineer at 2 a.m. isn't just being asked to respond to a real emergency, they're essentially being forced to play detective to divine whether the alert is even real in the first place. Like, does this actually matter to the users? Where do I even begin looking? Modern systems already heal themselves in tons of ways, through auto-scaling, failovers, load balancing, the whole shebang. So, when your system triggers a notification for a condition that just fixes itself, that's not an emergency. You're not building reliability at that point. You are literally just manufacturing burnout for your engineers.
These are your classic arbitrary threshold alerts, the usual suspects in low observability systems. We're talking about things like CPU spiking past 80%, available memory tanking, disk space maxing out, things like that. These alerts are tracking potential causes that honestly often don't even correlate to actual user pain. In traditional threshold-based monitoring, you basically write a check to measure a system state, draw a rigid line in the sand, and page someone if it crosses that line. But here's the problem. In modern distributed systems, failure modes aren't additive, they're combinatorial. It's like a giant puzzle where the number of plausible things that can go wrong is essentially infinite. You just can't write threshold alerts for issues you can't even imagine yet.
And when engineers can't reliably reason about all those wild combinatorial failures, production turns into what the text calls a glass castle. It becomes this beautiful, intricate monument to their collective design, but one they are absolutely terrified to touch, because any unforeseen movement could shatter the entire structure. If your alerts only fire on the known unknowns, your team is going to constantly be blindsided by the unknown unknowns, and that just breeds a persistent, exhausting culture of fear around deployments and routine changes.
All right, moving into part 1, decoupling the what from the why.
We absolutely have to stop writing alerts for specific system causes and start writing them for overall symptoms. Threshold alerting tries to fuse the what and the why together, assuming that high CPU automatically equals a bad user experience. But SLO-based alerting, it is purely symptom-based. It deliberately divorces the what from the why. An SLO alert simply raises its hand and says, hey, users are currently experiencing a degraded service. That's it. It's then up to the responder, using solid observability tooling, to debug from first principles and actually figure out the why. This shift is a real game changer because it drastically reduces noise. You only get paged when the actual customer experience is taking a hit.
Which brings us to part 2, defining reliable event-based indicators.
Understanding the relationship between these two terms is absolutely crucial. Think of an SLO as your internal goal. For instance, 99.9% of user requests to load the homepage should succeed. The SLI, on the other hand, is the actual measurement tool, the referee checking if you're hitting that goal. Now, the text strongly recommends using highly granular event-based SLIs rather than old-school time-based metrics. In a time-based world, if you look at a whole minute of traffic and a metric dips, that entire minute gets flagged as bad. But with event-based SLIs, every single individual user request is categorized as a pass or fail. This gives you a massively more accurate picture of your system's health, pinpointing exactly how many users are actually having a bad time.
Okay, so let's break down a practical example of how to craft an event-based SLI to determine if a user had a good experience loading a home page. First up, you qualify the event. You only want to look at telemetry hitting the /home route. Second, you set your success condition. Let's say it must load in under 100 milliseconds. Third, you verify the status to make sure it didn't throw an error code. And finally, you calculate. If a specific request takes 150 milliseconds, it gets categorized as a bad event, even if it technically succeeded and loaded, and you spend a tiny fraction of your allowed SLO error budget. This methodology is incredibly precise at measuring true user impact.
Now for part 3, a 12-week implementation case study.
To prove this isn't all just theoretical pie-in-the-sky stuff, consider this fascinating real-world example featuring Matt Vine, a cloud and reliability lead over at ANZ Bank.
His boss gave him a blistering 12 weeks to prepare for a major product launch. Now, the natural temptation under that kind of pressure is to just panic, right? To slap on some standard threshold alerts based on whatever performance they currently had and call it a day. But as Matt perfectly captures in this quote, falling back on that is a dangerous one-way trap. Those arbitrary thresholds calcify. You end up trapped in a noisy feedback loop, getting paged for minor statistical deviations that don't even impact the customer, which completely derails your engineering velocity.
So how did they pull it off? By strictly narrowing their focus to day-one customer journeys, Matt's team actually compressed what should have been a year-long rollout into just those 12 weeks. Because their services were already emitting standardized telemetry using OpenTelemetry, they didn't have to waste weeks writing messy data mapping rules. They completely skipped mapping every single service and just focused on less than a handful of truly critical user journeys for launch day. They proved for sure that a focused, high-quality implementation of SLOs can get you to market safely and rapidly, even if full integration across hundreds of workflows takes another 18 months to mature.
So you might be wondering, where do you actually start scaling this across a massive organization? Counterintuitively, you skip your highest performing teams. Seriously. High-performing teams already self-govern. They balance risk intuitively. SLOs just aren't going to move the needle much for them. Instead, you want to target the teams experiencing the highest operational stress, or the ones suffering from really fractured relationships with product stakeholders. Those are the environments where the objective, data-driven nature of Aero budgets is going to fundamentally shift behavior, reduce friction, and provide massive, immediate value.
Okay, moving on to part 4, accelerating SLOs with AI.
Let's be real, writing the perfect query logic for an SLI from scratch can be incredibly tedious. But by embedding best practices into a prompt using these specific components, you can use a large language model to rapidly draft highly accurate service level indicators. You just feed the LLM the name of the objective, the specific user journey, your target rate, like 99.99%, and the rules for how to evaluate if an event is eligible. The AI steps in and translates your plain English goals into the highly specific query language your observability tooling demands. It completely breaks down that technical barrier to entry.
When you actually run this, say, through Claude Opus 4.6, the results are honestly pretty incredible. The AI can write syntactically accurate logic that perfectly scopes something like checkout events and validates the success criteria. It even figures out that non-checkout events need to return a null value so they don't skew the data, ensuring both the HTTP status code and latency metrics are evaluated correctly together. By utilizing AI like this, you take a tedious, error-prone task and automate 90% of it instantly. That frees your engineers up to focus on the much higher-level architecture.
Now, we definitely shouldn't let perfect be the enemy of good here. Using an LLM to generate your first draft of an SLI might not be flawlessly perfect right out of the gate, but safely iterating on imperfect SLOs is infinitely better than gatekeeping reliability behind a wall of elite SRE expertise. If your tooling allows you to edit SLOs retroactively, the consequences of a slight mistake are minor. You just adjust, you iterate based on real-world feedback, and you end up empowering far more teams to adopt these robust reliability practices.
And finally, part 5, acting on SLO-based alerts.
Think of your error budget as the absolute maximum system unavailability your business is willing to tolerate. If you're tracking your remaining budget over, say, a 3-week period, every single failure chips away at that 100% mark. If you drop all the way to 0, you are out of compliance. And that typically triggers some pretty severe consequences, like total feature freezes just to refocus on stability. To avoid that fate, you have to track this gradual depletion and react long before the tank is empty, meaning your alerts need to be actively predictive, not just reactive.
And this is exactly where forecasting comes in. You can't just set a simple alert for when your budget hits 30% remaining, because a static number doesn't tell you how fast you are falling. Instead, we use a baseline window of recent historical data, maybe the last hour or the last day, and we linearly extrapolate that trajectory forward. Depending on the current rate of failure, we can predict exactly when the budget will cross that 0 line in the future. Are we crashing in 3 days, or are we crashing in 3 minutes?
Context-aware burn alerts are the absolute secret weapon here. Imagine you had 65% of your budget left yesterday, and today, boom, you're down to 35%. A context-aware alert evaluates this short-term, proportional drop against your long-term window. It realizes, hey, we are hemorrhaging budget at a rate that will exhaust everything in less than 2 days. This instantly triggers a high-urgency page, allowing your engineers to jump in, initiate an investigative response, and fix the underlying issue way before a catastrophic failure ever hits your actual users.
Ultimately, by focusing your monitoring strictly on the customer experience, And managing your error budgets proactively, you stop paging engineers for ghosts in the machine. You empower them to rely on robust observability data and ensure real, meaningful reliability for your users. Yes, the shift from arbitrary thresholds to event-based SLOs takes work, but the return on your team's sanity is just immeasurable. So here's the real question you need to take back to your team tomorrow. If an alert fires right now, and no user is actually suffering, why on earth is your pager even making a sound?